Welcome back, my Algebra 2 students. We're in lesson 46. We're going to talk more about radical expressions first. So we have been simplifying expressions like this. Very simply by breaking them down first using the quotient of square roots theorem into two parts, the numerator and the denominator both being their own square. So we would say negative square root of 2 over the square root of 3 plus 3 times the square root of 3 over the square root of 2, so that we could break them down and manipulate them. So now what we would be able to do is multiply both fractions by their square root denominator to eliminate the square root so that we could find something common between the two. So that would be quite simply negative square root of 2 times the square root of 3, which would be the negative square root of 6. And then the square root of 3 times the square root of 3 just leaves you with 3. Plus 3 times the square root of 3 times the square root of 2, which is the square root of 6. Square root of 2 times square root of 2 would just be 2. So now we have something that we can actually find a common denominator for and solve for. So I'm going to multiply this side by 2, which gives me negative 2 square root of 6 over 6, plus multiply this fraction by this denominator, and we have 9 times the square root of 6 over 6. Negative 2, positive 9, that would equal 7 times the square root of 6 over 6 as our final answer. And that is correct. So we simplify by breaking these down into separate parts within the same fraction, just squaring the top and the bottom independently instead of together. That's all we're doing. We break that. It keeps the same value because they are still both being squared, but it allows us to then manipulate them with the rule of multiplication for both the top and the bottom. Right? Because if we multiply something in the top, we have to do the same thing in the bottom to keep it the same value fraction. Remember that from our very, very long ago basic math. Keep it true. 1/2 is equal to 2/4 is equal to 3/6 is equal to 4/8. As long as you have the same number multiplying the top and the bottom, the fraction remains the same value. Same thing here. That's all we're doing, is we are breaking it down so that we can manipulate it and put it into something that is more simplified. So let's do 46.1 along those lines. So 46.1 says 3 times the square root of 2 over 7 minus 5 times the square root of 2 over 7 plus 3 times the square root of 56. So the first thing that I would do is break these down. 3 times the square root of 2 over the square root of 7 minus 5 times the square root of 2. Did I write that right? No, I didn't. I didn't think so. This is supposed to be 7 over 2. Sorry about that, guys. So that'd be 5 times the square root of 7 over the square root of 2. That makes more sense, because usually the book contrives something where you have to get the same common denominator, and it works it out ahead of time for you so it knows what those numbers are going to be. All right, for this 56, I would actually try to solve something out of here. And I know through the use of my trusty calculator that the square root of 4 times the square root of 14 is the square root of 56. So what that means is I could pull this and do 2 as a factor. So I can rewrite this as 3 times the square root of 2 over the square root of 7. Actually, what I'm going to go ahead and do is say square root of 7 times this would give me 3 times the square root of 14 over 7 minus, and I'm going to do square root of 2 times this, 5 times the square root of 14 over 2 plus 3 times 2, 6 times the square root of 14, and then I'm going to put this over 1 and turn it into a fraction. So now I can find a common denominator between all of these. And obviously, looking at these numbers, our common denominator is going to be 14. So I'm going to multiply this entire fraction by 2. So that gives me 6 times the square root of 14 over 14 minus this times 7. So that'll be 35 times the square root of 14 over 14 plus, this is 1, so I have to multiply this by 14, and that gives me 84 times the square root of 14 over 14. Now I can do some math. And 6 minus 35 plus 84 is 55 times the square root of 14 over 14. And we can't reduce this any further, so this is our final answer. All right. If you are having any trouble following this logic right here, please let me know. Let me walk you through it. All right, that was 46.1. Now we're going to talk about taking radicals to fractional exponents. So let's do a little review. So we've learned that if we have 4 to the 1/2, 1/2 is simply another way of writing the square root of. Because we have, this is the exponent that's tied to the number. This is the exponent. And then this is the radical. Okay, it's exponent over radical. So if I have a number that looks like this, we know that that is going to be the cube root of 8 squared. Right? We don't have to solve it. We just have to know how to translate it. And if I were to say 11 3/4, that would simply be the 4th root of 11 cubed. We just have to know which number goes where. That the one touching the number is the exponent, and the one that is the denominator is the root index. Right? So this would simply be this. Because the default index is 2, so we don't have to write it. And the default exponent is 1, so we don't have to write it either. Okay? So, if you don't have this written down, the one next to the number is the exponent, the numerator is the exponent, the denominator is the radical index. That is something you want to do. And that's going to help us go backwards as well. So let's make sure you write that down, and then I'm clearing the page. Pause it if you need to. So now let's go backwards with that. Let's simplify this. We have 46.2. We have the square root of 3 times the square root of 3. Or I should say, the way to correctly say that is the square root of 3 times the square root of 3. Right? So in order to do that, we have to work from the center out in order to put this into a fractional exponent. So we start with the one in the middle. All right, this is an exponent of 1, right? and it's under a square root sign. So that is our radical. So let's put this in a parenthesis by itself, because now we have to do this one. So now we have 3 times that, and it's to the exponent of 1 underneath the square root radical. Right? But it is for the whole thing, like this. So we'll start with separating these out. So first we'll multiply this times this and rewrite it, 3 1/2. And then we'll multiply this times this and rewrite it, because we know 1 times 1 is 1 and 2 times 2 is 4. Right? We multiplied our exponents. We applied 1/2 to this and 1/2 to this. Now we're going to multiply these. And the way we do that on this scale, because we don't have an exponent, a fractional exponent on the outside, now they're against each other, and it's like saying 3 1/2 times 3 1/4. That's what we're doing. So now what we have to do is treat these the same way we would treat them if they were fractions, and find a common denominator and then combine them. So the common denominator here would bump this up to 2/4. So we have the same denominator. Now we could put them together. We add our exponents and we have 3 over 3/4. Or 3 3/4 is our exponent. All right. So when we have a radical that's over the top of another radical, we bracket that all together and put our fractional exponent on the outside. Because it's the square root of 3 times the square root of 3. That's how you would read that. The square root of 3 times the square root of 3. And that's how we would solve that. So technically, this becomes the 4th root of 3 cubed. That would be how you would reduce that down. Kind of interesting, right? All right, let's do 46.3. Let's do it right here. After we do a few of these, you'll start to get the hang of them. So we have the cube index of 3 times the square root of 3. So again, we start with the one in the very, very bottom, and that's going to be 3 1/2, because that's square root. And now we have a bracket. We do 3, and we have our bracket, and we have the cube root. Okay. Now we multiply. We have 3 1/3 times 3 1/6, because we applied this to here. So now we have to find the common denominator, which would be 6. So that would make this 2/6. So 2/6 plus 1/6 is going to equal 3/6. So that is that right there. And that translates to the 6th root of 3 cubed. That's what that translates into. All right. Starting to get the hang of them. All right, let's do 46.4. Let's clear this page. Take your notes. You're going to want to remember how to work these. That's what sample problems are all about, is being able to go back and look and see how to work a problem like this and follow the steps. All right, let's do 46.4. This one has variables. So now that you're starting to get into variables, it's a little bit more abstract. This is x squared y cubed, or squared, sorry, x cubed y squared. And then the cube root of xy. All right, we replace the radicals with parentheses and fractional exponents, and we get this. We get that is going to be this, because all of this was under the square root, and this is the square root fraction. And this is going to be times xy to the third, because it was under the cube root radical. Now we can multiply these. So we apply this to both of these, right? So what we end up with is 1/2 times 3 is x and 3 over 2. And then this becomes y. And 2 times 1 is 2. So it's 2 over 2 is 1. So it's just going to be y by itself. X times 1/3 is going to be x and 1/3. And then we have y to the 1/3. Right? We finish by multiplying the exponential expressions with like bases, and we convert these to have a common denominator. So 2 and 3 is going to be a common denominator of 6. So I'm going to multiply this by 3, and I'm going to get x and 9 over 6. And I'm going to calculate or multiply this by 2, and I'm going to get x and 2 over 6. And then I have my y. And I am going to multiply the y and get times 3, so it's 1. So 3 over 3 is what that 1 turns into. And then I still have y and 1/3 here. So now we add, and we end up with x to 11 over 6 times y to the 4 over 3. And that is correct. It's a little confusing, but your fractions are following the same rules they've always followed as far as common denominators, but yet they're also following the same rules as exponents when you multiply the bases together. So everything you learned about fractions plus everything you learned about exponents is thrown together in this one type of problem. So let's do another one. Let's do example 46.5. And we have the cube root of x to the 5 power, or the power of 5, times y to the power of 3, times the 4th root of x, y to the 5th power. So the first thing we're going to do is put these in parentheses and give it that index of 1/3. That's our exponent of 1/3. And then we're going to do the same thing here. We're going to put this in parentheses, x, y to the 5th, and we're going to give it that index of 1/4. That's our exponent. Now we're going to multiply them individually. So 5 times 1/3 is x and 5 over 3. And then y, 3 times 1 is 3. So that's, again, y is just going to be 1. Right? Because 3 over 3 is 1. So now we do the same thing here. X times 1/4 is x and 1/4. And y to the 5th times 1/4 is going to be y 5 over 4. Now we find that common denominator for the x's. It's going to be 12. So we're going to say x and 5/3 times 4 is going to be 20 over 12. And then this one's going to be 5 times, or 3 times 1/4. So x times x to the 3 over 12. Y is going to have a common denominator of 4, so this should be y and 4 over 4. And y and 5 over 4. Now we're going to combine. So it's going to be 23 over 12 for this x. So x is 23 over 12. And y is going to be 9 over 4. And because this is a prime number, we can't reduce that. And because there are no common factors, we can't reduce that. So this is our final answer. All right, and that is all we have for radicals to fractional exponents. And I will see you guys in lesson 47.